Hello, this is Group 21, presenting our project VRClassroom by Ethan Osorio, Dewey Vu, Aidan Bowen, Matt Latendress, and Luke McCumber. Our project's purpose has changed slightly from last time. Now, we focused on making a virtual reality sandbox where the player can interact with their environment and explore the different capabilities of Unity and VR through physics and other games. We originally wanted to create a multiplayer classroom where students and teachers could connect. However, it became very difficult as Unity and Oculus packages often became deprecated very quickly, so our network code constantly had to change or would not work anymore. With little documentation on Unity and VR in general, that is why we went a different route with the project and tried creating as many interesting features as possible instead. Unity is the game engine with the Oculus Quest 2 as our VR headset. We are using the OpenXR package to combine the two together. In addition to creating our own models, we are utilizing the Unity Asset Store for custom packages and models. The C# language is used in Unity as scripts are attached to any game objects that need code. Our environment has changed slightly from last time. We have added different features and used different assets to make up the background, but we decided to stick with a classroom setting. Features like the grabbable marker and whiteboard drawing were kept because it is something that the player can interact with. The same original marker model and prefab were imported and used for the project. While playing around with the physics of Unity, we created a stapler that shoots out staples by pressing the trigger button. The stapler is interactive, so any other interactable game objects can be affected by the little staples. If hit, the game objects will be knocked back. This is done by spawning small staple game objects and adding physics that change their location and speed when fired. Another feature we added was teleportation. Originally, we made it so that the player could teleport by pointing the red ray and pressing a trigger and they would teleport to that location. But we decided that it would be better to have beacons that the player could point at and click and they would teleport to the beacon's location. While exploring the capabilities of Unity with VR, we found that we could use cameras other than our headset to display different parts of the world. With this, we were able to create a functioning mirror where you can see yourself and objects around you. We did this by attaching a camera game object to a plane that would track the player's head, and then we inverted it. We attached it to a frame so then it gives off a mirror effect. Anything in its path is revered left to right but not top to bottom. The tracking allows you to see yourself from different angles around the mirror. From the last video, we used an asset package from the Unity store to decorate our background and environment. However, it caused many performance issues as our game lagged quite a bit when near the game objects. We decided to import a new asset package that looked better and would not bring about lag. We found and used a low poly asset that included various trees, grass, flowers, and other terrain. The low poly aspect allowed for better performance and less lag but still looks nice. It uses custom textures and materials rather than the ones given by Unity. It also uses custom shaders. Shaders are small scripts that contain the mathematical calculations and algorithms for calculating the color of each pixel rendered, based on the lighting input and the material configuration. This gives the objects a brighter feel and it interacts with sunlight and shadows much better. Here we can see the individual models of various prefabs. Usually, each game object is made up of smaller game objects that are then combined together. This allows for a wider range of customizability with coloring and even animation. If you looked closely at the trees from the environment, the leaves and fruit actually moved around as if there was slight wind blowing in the game. To do this, dozens of animation clips for each leaf are created to replicate how it would look when in the wind. These clips are added to an animator controller stores these clips and blends them together fluidly. The controller is then attached to the game object and mapped to each component that needs to be animated. In the end, the tree is able to reference the clips in the controller so that it can move. Since we wanted to create a fun interactive sandbox, we decided to use the physics engine in Unity and replicate a game out of it. So we created a separate scene where you can go and play mini golf. The course was designed with the low poly asset, while the course materials were imported through a different golf asset from the store. The player can play through 5 holes with various obstacles that a real mini golf course might have. Their right hand is always attached with a club that is used to hit the ball. Obviously, the goal here is to get the ball in the hole in the least amount of strokes possible. Though it might be because the player here is bad at golf, the hit detection is not always perfect with the club and ball collide, and when the ball rolls on the ground. Here is a snippet of the many scripts that is attached to the club collider. It involves a lot about recording the position of the club and then calculating the speed at which it moves. Then it determines the velocity for whatever object is being hit, is going to move and in what direction. This allows the club to hit the ball and for the ball to move, but also have drag. You can also hit the ball at different angles like in real life. However, since the colliders or hitboxes of these game objects are not perfectly fit to size but more like big boxes that cover all of them, the hit detection can be inconsistent, so we hope to improve that greatly in the future. Along with fine-tuning the other features, we also hope to add more games like this, as it is a great way to showcase the Unity engine and virtual reality together. Though it can be difficult to learn, you can be very creative and build many cool things in VR.